Let's solve some questions in tutorial sheet 5, Binomials 2025. Okay, so without wasting much of the time, let's start with the first one. So if n plus 1 factorial is equals to 5n factorial, so for n, so this is a binomial equation. So how are we going to go about it? Now you must know that if we write something like 5 factorial, 5 factorial is just the same as 5 times 4 times 3 times 2 times 1. Whatever number, you're just going to trickle it down like that. Therefore, our n plus 1 factorial is just the same as n plus 1. Then we're going to subtract a 1 from it. Okay, and when we subtract a 1 from it, n minus 1 and minus 1, so we're just going to have an n, right? So n. Now I can end that here, or if I want I can be going like that. So it is just the same as that. Why am I've ended here? Because we've got a 5 n factorial on the other side. So I'm going to say n plus 1 n factorial is equals to 5 n factorial. Now I can divide the n factorial on both sides because I want just to find the value of n. Okay, so the n factorial, they'll go. Therefore I'm going to remain with n plus 1 is equals to a 5. Now when I reach here, I put the like terms together, so n will be equals to 5. When the 1 comes to the other side, it changes the sign and it becomes a minus 1. Okay, therefore our n in this case is equals to a 4. So this is our answer. Let's solve the second question. Now we are told to show that n choose 1 is equals to n, and the second one is for us to show that n choose 2 is equals to n, n like that. Okay, so now this is called a combination. Okay, so according to combinations, if I've got n, let me say choose 1. N choose 1, what it means is that we're going to find n factorial, or let me write it like this, because it's a combination, I'm going to say n combination 1 or n choose 1. This is just the same as n factorial over n minus 1 factorial and 1 factorial. So this is a general way of solving factorials in terms of combinations. So now we're trying to show, so it means we have to prove if n choose 1 or n combination 1 is going to give us n in this first expression. So we can start. So what are we going to do? The same principle, n combination 1 is just the same as n factorial over n minus 1 factorial, then 1 factorial. Then we just have to solve. Now n factorial on top, n factorial is just the same as n minus 1 when you subtract the 1. If you want, again, can subtract another one, n minus 2, and you'll be going like that. You just be subtracting by 1. But as for me, I'm going to end at n minus 1 factorial. Why am I ending there? Because I'm taking advantage of the n minus 1 factorial that is down. So I'm going to write n minus 1 factorial over n minus 1 factorial. Then I've got a 1 factorial. Okay, these are factorials, so here it was also supposed to be 1 factorial. So this and this can divide. Okay, therefore what am I going to remain with? On top I have an n, down I've got a 1 factorial. Now 1 factorial is just the same as 1, and n divided by 1, I'm just going to get an n, hence proven. Okay, hence proven, because the left hand side is equals to the right hand side for the first one. Now let's solve the second one. How do we prove the second one? So it's not much different from the first one. So we are going to say we are trying to prove n choose 2 or n combination 2 if it's equals to that. Let's try. So we're saying n combination 2 will just be equals to n factorial over n minus 2 factorial, then 2 factorial. Then we just have to simplify this expression. Then, like I said, the n factorial on top is just the same as n. Then we're going to subtract a 1, so it will be n minus 1. Then again we're going to subtract another one, n minus 2. Again, if you want, you can subtract another one, n minus 3, and you'll be going like that. But for me, let me end at n minus 2 factorial. Okay, so n minus 1, n minus 2 factorial. I've ended at n minus 2 factorial because there's an n minus 2 factorial down, then a 2 factorial. Now let's solve. So the n minus 2 factorial and the n minus 2 factorial, they can divide. Okay, then what do I remain with? You're able to see that on top I only have n minus 1 is equals to, down I have a 2 factorial. Now a 2 factorial is just the same as 2 times 1. 2 times 1 is just a 2, so I have a 2. Now you're able to see that this is equals to the, the right hand side. It's just the same. So hence proven. So that's how you prove binomial, expansions. Then let's solve another one. Simplify the factorial expression. Okay, so even this one is very straightforward. Simplify the factorial expressions. Let's start with the first one. So we've got 2n plus 2 over 2n factorial. Okay, on top there's also a factorial. Okay, so what are we going to do to what is on top? So to what is on top, we're going to be subtracting by 1, like we've said. So I'm going to write the actual expression first, 2n plus 2. Then let's subtract a 1 from this. You know that when we subtracted 1 from this, it will just be 2n. Since we've got a positive 2, when you subtract a 1 from that 2, you're going to have what? A 1, right? Plus 1. Then again, from this 1, again, we subtract another 1. So you're going to have a scenario where we've got 2n plus 1. When we subtract another 1, so we're going to have 2n. The 1 minus 1, they'll just give us a 0, okay? So we just have 2n. Now, 2n. If I want again, I can subtract another 1. From 2n, I subtract another 1, I'm going to have 2n minus 1. I can write it here. But I'm not going to write it there because I've seen that there's a 2n minus 1 factorial down, so I'll end at a 2n minus 1 factorial over 2n factorial. So now what do we have? What do we now have? So I can divide the 2n minus 1 factorial. This one and this one, they're going to divide. Then what do I have? I've got that expression on top. Okay, now what I have on top is just the same like you have x plus x, and when you have x plus x, it will just give you 2x, right? Okay, but actually it's not the same. There's a plus 1 there. Okay, so it just means that you're supposed to multiply those ones. Okay, which I'm not going to do. If you want to express them, but would have simplified the factorial expressions. We've simplified the factorials that we initially wanted. Let's solve the second one. Okay, the second one, we're saying n plus 1 factorial over n minus 1 factorial. So how are we going to solve this one? So to the one on top, we're going to do the same. We're going to be subtracting by 1. Okay, so because we're subtracting by 1, we're going to write first the first expression, Then we subtract by 1. When you subtract by 1, you know you have n plus 1. When I subtract by 1, this will give me a 0, so I'll remain with n. So I'm going to write my n. Then to this n again we subtract a 1. You know that we are going to have n minus 1. And if you want again to this n, if you want to subtract another one, we're going to have n minus 2, and will be going. But I'm going to end at n minus 1. Why? Because there's an n minus 1 down. So I'm going to end at n minus 1 factorial. This will be over n minus 1 factorial down. Okay, when I simplify the factorials, what am I going to have? This n minus 1 factorial and this n minus 1 factorial, they are going to divide. And what am I going to have? I'm just going to have n multiplying by n plus 1. So this will be my final answer. We've simplified the factorial expressions. Then we can solve another one. Now calculate the binomial coefficients. Okay, we know that the coefficient is just a number that is in front of a letter. But now these are combinations. Okay, so let's start with the first one. So we've got 4 choose 2 or 4 combination 2. So how do we solve this one? We say 4 combination 2. This is just the same as 4 factorial over 4 minus 2 factorial. Then I have a 2 factorial. Then I just have to express this one. I have 4 factorial on top over 4 minus 2, that is just a 2. Then there's a factorial, then there's a 2 factorial. Now let's solve. What is on top? I can simplify it. I'll be subtracting by, or I'll write it as 4. You know, 4 factorial is just the same as 4 times 3 times 2 times 1. But let me not end at 1. I'll end at 2 factorial. Why I'm ending at 2 factorial? Because there's a 2 factorial down. Okay, 2 factorial and 2 factorial. So what am I now going to have? You know that 2 factorial and 2 factorial can divide, and they'll just give us a 1. Then 2 factorial down is just the same as 2. 2 times 1, that is just a 2. So this is just the same as 2. Now 2 into 2 is 1. 2 into 4, that is a 2. So you're able to see that on top I've got a 2 and a 3, and when they multiply, I'm just getting a 6. So that's how we solve for the first expression. Now let's solve for the second one. We've got 8 combination 5. So we're saying this is just the same as 8 combination 5. And the way we solve this one, it is 8 factorial over 8 minus 5. Now I can subtract in advance. 8 minus 5, it is just a 3. Okay, 8 minus 5, it is just a 3. So I'm going to write 3 factorial 5 factorial. Then when we simplify the 8 that is on top, I'm going to have 8 multiplied by 7 multiplied by 5 multiplied by, I can go multiply by 6 actually. 5 from 7, we're going to 6 multiplied by 5. I can go until, but let me end at 5 factorial. Why am I ending at 5 factorial? Because I'm taking advantage of the 5 factorial that is down. Okay, so I've got 3 factorial, 5 factorial down. Then what am I going to do? The 5 factorial and the 5 factorial can divide. Okay, then the 3 factorial that is down, 3 factorial that is down is 3 factorial is just the same as 3 times 2 times 1. And when I do that, 3 times 2, that is a 6. A 6 times 1, that is still a 6. So here I've got a 6 down. The 3 factorial is just the same as a 6. So the 6 can divide and the 6 can divide. Therefore, on top I only have 8 times 7. 8 times 7, you just know that it is just a 56. Okay. Allow me to rub to solve the other two. Now we've got 12 combination 1. Okay, this is just the same as 12 choose or combination 1, which is just equivalent to 12 you know, 12 factorial over 12 minus 1, that is 11. Okay, so we have 11 factorial multiplied by 1 factorial. 1 factorial. Okay, so what do we now have? So how are we going to solve this one? 12 factorial is just the same as 12 12 minus 1, that is an 11, then a 1 factorial. Okay, so what do we now have? We are going to have 12 multiplied by, when we subtract the 1, 11, and we can just end at 11 factorial, okay, over 11 factorial multiplied by 1 factorial. Okay, the 11 factorial and the 11 factorial can divide, therefore just going to have a 12 on top. Okay, we have a 12 and we are done. Okay, simple, straightforward. Then we have n minus 1. Okay, so how are we going to solve this one? Okay, allow me to rub so that I solve the last one. So we're saying we have n minus 1. Okay, so how are we going to solve this one? So we're going to say n combination n minus 1, which is just the same as n factorial over n minus this way expression n minus 1 factorial. Allow me to put this one in factorial, then the same n minus 1 factorial. Okay, so this is very much interesting. So how are we going to solve this one? So what we are going to do is, should I distribute? If I distribute, sorry, it is positive. Okay, let me solve what is in this bracket. I see what it gives me. Okay, so that one is n minus 1, then there's a factorial. Okay, so we're going to have, when I distribute n, when I distribute the negative, I'm going to have negative n plus a 1. Okay, now when I solve that, I've got n minus n, that is just a 0. Okay, a 0 plus a 1, that is just a 1, right? So I remain with a 1, then there's a factorial. Now a 1 factorial is just the same as 1, right? So this way expression gives us a 1. So what do we now have? We have n factorial on top over 1 multiplied by n minus 1 factorial, n minus 1 factorial. Then what do we do? Now we can simplify. I've got n factorial, so n factorial is just the same as n. When I subtract the 1, I have n minus 1. If I want to subtract the 1, I would have n minus 2, but I'm going to end at n minus 1 factorial because I'm taking advantage of the n minus 1 factorial that is down. Okay, so the n and the n minus 1 factorial, they're going to divide, therefore my final answer is just going to be an n. Okay, so we are done for this one. Let's solve the last question for this segment. So what do you now do? We're sure to show that n over n is equals to n choose 0 is equals to 1. Okay, now you know that okay, it's the same thing. So let's start with the first one. If we see if it's going to give us 1, n choose n, what is it going to give us? So it's just the same as n combination n, which is just the same as n factorial over n minus n factorial, then n factorial. Okay, now I must make mention something. So okay, let's first solve this one. So we've got n factorial over n minus n, that is 0, right? 0. So 0 factorial, then we've got n factorial. Okay, now 0 factorial is 1. Okay, 0 factorial is 1. So we have 0 factorial, which is 1 multiplied by n factorial. So the n factorial and the n factorial can divide, which will just give us a 1. Okay, for the first one we found a 1. Let's come now to the other one. The other one, it is n combination 0. So we are saying n combination 0 or n choose 0 is just the same as n factorial over n minus 0 factorial, then 0 factorial. So the n factorial on top over n minus 0, that is just n, so to be n factorial. 0 factorial is just the same as 1. So because it's the same as 1, we are going to we will not put the 1. Okay, so n factorial divided by n factorial, this just gives us a 1. Hence, because we are showing, so you are going to write hence proven.